So here we have another circuit where we have this sinusoidal signal source E connected to the network consisting of resistance and inductor L, and the total current that is being fed by this signal source is I. That I gets distributed between two parts, that is IR and IL. IR is the current flowing through the resistor, IL is the current flowing through an inductor. When IR flows through resistor, it generates a voltage drop VR. When IL flows through an inductor, it generates a voltage drop across it called as VL. So we can write total voltage E is your VR, and it is nothing but VL, and the total current I is IR plus IL. Similarly, you have VR, that is IR times R, and VL, that is IL times XL. XL is the reactance of an inductor. So we know that sum of two currents is the total current I, and the voltage across inductor is equal to voltage across resistor. Okay, and if you want to calculate any one current, so you can use this equation to calculate a current flowing through a particular branch. Let us understand what could be an impedance. When you look into the input side of the circuit, let's call it as a Z in. So you remove this voltage source and look into the circuit across its open terminals. So the circuit looks like this. You have resistor, you have an inductor, this is R, this is L, and you keep the circuit open like this, and the impedance would be across the terminal 1 and 2. So Z in can be written as a parallel combination of R and L are there, so resistance of a resistor in parallel with reactance of an inductor. So it would be R times XL divided by R plus XL. So XL is angular frequency omega multiplied by the value of inductor, and that is also omega L. So you see that Z in is your function of frequency. Omega is angular frequency. Remember, omega is equal to 2 pi f. F is the frequency. So that is how you actually can analyze the circuit for input impedance, for various voltages, and to calculate various currents. Okay, and that is how you will analyze the circuit.